Section 6-7 is the last section for Unit 7 before we'll do our sample test and test. We're going to find the area of triangles and quadrilaterals. So we'll go through and we'll talk about all of our area formulas. The first one, the area of a square. Some of you guys know this as length times width. Really, because the sides are the same, we can call one side S, then another side is S, and so it's S squared. You could still think of it as length times width. However, a lot of times we'll just give you the length of a side. We'll give you S. You're going to take that number and square it. For example, for our square, number 1 says that S, the length of a side, is 7. To find the area, we're going to take S squared. 7 times 7 is 49. So this is 49 square units. We weren't given if this is feet, inches, centimeters, so it's units. When you find area, it's always units squared. It doesn't change the number, that's just on the label. Working backwards, if I know that S squared is 64, then to find the length of a side, I'm going to do the square root of both sides because a square and a square root are opposites. I don't really need to consider the plus and minus on the square root because I can't have a negative length. So we're just going to take our positive or principal root, and so our answer is 8. Number 3, still working with squares. If the area of our square is 12 and we need to find the length of a side, we're going to find the square root of 12 because side squared is 12. So we do the square root. Do not give decimal answers. We are going to simplify the square root. So we're going to take our 12 and do the factor tree. I know 4 times 3 is 12. 4 is 2 times 2. And we're looking for pairs. One number from the pair comes out. If you have more than one coming out from a pair, you multiply those. Any lonely numbers that don't make pairs stay underneath. So our answer for the length of a side is 2 rad 3. Next, we'll move on to the area of a rectangle. The area of a rectangle is base times height, which is like a length times a width. Again, any units put on would be units squared because we are multiplying two separate things. So if I know the base is 8 and the height is 4, we're going to do 8 times 4 and find that the area is 32 square units. We'll also do somewhere we're working backwards. Again, our formula is area equals base times height. This time I know the area is 84. I know the base is 7, and we're looking for the height. And if you get stuck, just plug in the numbers to the formula, and then you're going to solve for the missing letter. So I'm going to solve for height. These are multiplied, so we'll divide by 7, and our height is 12. You do need to know all of the formulas for areas. You need to make sure you have these memorized and you know which one goes with which figure or with which picture. The next one, we'll move on to area of a parallelogram. Parallelograms are quadrilaterals with both pairs of opposite sides parallel that we've talked about those properties of. The area of a parallelogram is still base times height, and the reason for this is because those opposite sides are parallel and opposite sides are congruent. You could actually take this triangle on the left, and if you remove that, it fills in the space on the right and it ends up forming a rectangle. So the area of a rectangle and the area of a parallelogram are both base times height. The first parallelogram example, we have that our height is 7/8, our base is 3/5. So since area is base times height, we're going to take 3/5 times 7/8. Now when I multiply fractions, I multiply straight across the top and straight across the bottom. 3 times 7 is 21. 5 times 8 is 40. That cannot reduce, so 21/40 is my area. Same formula, area is base times height. Again, plugging in what we know, I know that the area is 63, base is missing, the height is 9. Then we're going to solve for the missing part, the base. Since these are multiplied, we'll divide by 9, and the base is 7 units. So squares, rectangles, and parallelograms all kind of work the same. The next figure we're going to talk about is the area of a triangle. The area of a triangle is base times height divided by 2, or 1/2 base times height. It's the exact same thing, so whichever way you're most comfortable with. The base will just be this side of our triangle, The height goes from the opposite vertex down to that side at 90 degrees, so it hits perpendicular. So we're going to use our 1/2 base times height and work through some examples, or you can use base times height divided by 2. So area is base times height divided by 2. I know my base is 16, my height is 7, and I'm going to divide that by 2. And you have options for how you could start solving this. So option 1 is I'm going to multiply across the top, take that number and divide it by 2. So the first way I could solve this is I could do 16 times 7, which is 112. Then I'm going to divide that by 2. 112 divided by 2 is 56. So area is 56 square units. The other thing I could do, so option 2, is when you have something like this that's multiplied on top and then divided, you can divide one of these numbers by the 2 on bottom, but not both. So if, for example, you weren't really comfortable with the 16 times 7, doing that as middle math and didn't have a calculator, you can do 16 divided by 2. But since this is multiplication, only one of those numbers on top gets divided. So 2 divided by 2 is 1, 16 divided by 2 is 8, 8 times 7 gives me 56. So we want to make sure you have some options for how to solve these. Working the area of a triangle backwards, again, base times height divided by 2. So I'm going to write down my formula. And you need to be able to solve these if you're given any information. So you might be solving for area, you might be solving for the length of a base, you might be solving for the height. So I know my area is 12, and that's what I get when I do the base 4 times height is missing divided by 2. Now I'm going to undo this problem. So to start, I'm going to get rid of the fraction. The opposite of dividing by 2 is to multiply both sides by 2. So we have 24 equals. Remember from when we talked about using midpoint backwards, we solved some problems like this. The 2 out to the side and the 2 on bottom always just cancel out. So 24 equals 4h. We'll divide by 4. And h, the height, is 6 units. I can double check this by sort of plugging back into the formula. 4 times 6 is 24, divided by 2 does give me 12. So I know I got that problem right. Following that formula, we know that the area of a triangle is base times height divided by 2. The area of a trapezoid is similar to this, but there's 2 bases. There's those opposite bases that are parallel. So this is the quantity of base 1 plus base 2 times height divided by 2. So I have to add up the bases, multiply by the height, and divide by 2. Let's look at an example. So the area equals base 1 plus base 2 times height divided by 2. This time I am solving for A. I'm looking for the area. My first base is 8. The second base is 3. Those are those parallel sides that are opposite each other. The height is 10. And we're going to divide by 2. So I'm just going to follow order of operations. 8 plus 3 is 11. And again, you can do 11 times 10, 110 divided by 2, and you get 55. You could divide these and do 11 times 5, and you would still get 55 square units. Let's try another one. Still a trapezoid. Area of a trapezoid is the quantity of base 1 plus base 2, and those are just subscripts representing the 2 bases, times height divided by 2. Again, you could be asked to solve for any part. So the information I know that the area A is 99. The first base is 12. Base 2 is missing, so I'm just going to leave that as B2 times 9 divided by 2. Now I'm going to undo the problem to solve. So just like when we undid the triangle equation to get rid of divided by 2, I'm going to multiply by 2. So we have 99 times 2, which is 198, is what we get when we add 12 plus base 2 times 9. Now instead of distributing, since this is multiplied by 9, I could divide by 9, or I could go through and I could distribute. It's totally up to you. Distributing actually causes you to have one more step, so I'm going to divide by the 9. So 198 divided by 9 is 22. So 22 equals 12 plus base 2. To get base 2 by itself, I'm going to subtract the 12, and I find that base 2 is 10. Again, I could double check. Base 1 plus base 2, 12 plus 10 is 22, times 9 is 198, divided by 2 is 99. So I know I got it right. So the area of a triangle and the area of a trapezoid are similar. The next formula we'll look at is the area of a kite. The area of a kite looks a little bit different. To find the area of this figure, you're actually going to take the length of your diagonals. So here's a diagonal, and here's a diagonal. One of these is diagonal 1, the other one is diagonal 2. We'll multiply those and divide by 2. So you're multiplying the length of the two diagonals and dividing by 2. So the first example for a kite, the first diagonal is 9, the second diagonal is 8, and we're finding the area. So it's D1, D2, divided by 2. So I'm going to take 9 times 8, divided by 2. 9 times 8 is 72, divided by 2 gives me 36 square units. The next kite example, area is D1 times D2, divided by 2. This time I know the area is 100. I'm missing the length of the first diagonal, but I have that the second one is 20, and then we have divided by 2. I'm just going to undo this problem, and there's a couple different ways you could solve this, and if you think that maybe another way would make sense, feel free to ask about those when we take questions during class. To get rid of divided by 2, I'm going to multiply by 2. So on the left, that will give me 200. On the right, remember, those just cancel. So 200 is 20 times D1. We'll divide by 20, and the length of the first diagonal is 10 units. So we can give you any part, just plug in what you know and solve for the missing piece. The nice thing is the area of a rhombus is exactly the same. You're going to take the length of the first diagonal times the length of the second diagonal, multiply those together, and divide by 2. So our first rhombus example, we know that the length of the first diagonal is 3. The length of the second diagonal is 11, and again it's D1 times D2 divided by 2. So area is 3 times 11 divided by 2. 3 times 11 is 33. Divided by 2 is 16.5 or 16.5 square units. And that's okay that we got a fraction. The next rhombus example, again, area is D1 times D2 divided by 2. So area, 21, equals the length of the first diagonal, 6, times the length of the second diagonal is missing, divided by 2. To start solving, I'm going to multiply both sides by 2. The 2's will cancel on the right, so we have 6 times the length of the second diagonal equals 42. We'll divide by 6, and we find that the length of the second diagonal is 7 units. Homework we'll be working on during class, we're going to be on page 376 to 377. We'll work on 14 through 31, 35 through 38, and we'll also be working on handout 7D.